Okay, number 16. Tiffany, can you read number 16?
Hmm?
Read number 16 first.
The 2-point charges of values positive 3.4 and positive 5.3 microcoulombs are separated by 0.1 meters. What is the electrical potential at the point midway between the 2-point charges?
Okay, so this is 3.4. This is 5.3 microcoulombs. And they're asking, what are they asking for?
Electrical potential.
Okay, what is the symbol for electrical potential? Class, what is the symbol for electrical potential?
It's
Okay, so that's a problem. If you don't remember what the symbols represent, then how would you be able to know which equation to use? We've done several examples just, a few problems ago on electrical potential. Which symbol did I use for electrical potential? Armina?
what symbol that you use for electric potential?
Yes.
Electric potential you use E, right?
Okay. So V is equal to K times Q over R. So if you have two charges, what do you do?
Don't you have to?
Okay, you just find the V from each charge and add them up. Okay. So what I'm saying is at this point, V is equal to V1 plus V2, which is K times Q1 over R1 plus K times Q2 over R2. Your Q1 is 3.4 times 10 to the minus 6. Your R1 is 0.05 because it says midway. Okay, so your R1 and R2 are both 0.05. And then your Q2 is 5.3 times 10 to the minus 6. And since both are positive, electric potential is the scalar. So you just add it like numbers. You don't need to worry about whether it's positive, whether it's to the right or to the left. Does that make sense?
Yes.
So electric potential is a scalar. If Q2 was negative, then V2 will be a negative number. So you'll be adding a positive number to a negative number, and then the answer will give you the potential. And in this case, the correct answer is plus 1.5 times 10 to the 6 volts. Okay. Number 17.
And
Okay.
what is from a point charge of 7.6 microcoulombs with the electrical potential be 4.9 times 10 to the 4 volts.
So that's your charge right there. At what point? That means they're asking for your R. Will the electric potential be so you know V, you know Q, you know K. So you know this. You know this, you know that. You don't know R. How could you find R? V equals
KQ over R.
KQ over R. So that means R equals
KQ over V.
KQ over V. And that will give you 1.39 meters. If you plug in 8.99 times 10 to the 9, and then your Q is 7.6 times 10 to the minus 6 coulomb. Your V is 4.9 times 10 to the 4. Okay? And number 18, what is the equivalent capacitance for the combination? Okay, so we know that I'm just going to give you the answers to this because I'm running out of time to get ready for the next session. So these two are parallel to each other. And the way you add capacitors in parallel is you just add them. So C parallel is just equal to C1 plus C2 plus C3. And then for series, you take the reciprocal C1, C2, minus 1. Okay, those are the two equations. So this is parallel. So 8 plus 6 is 14. And then when you combine these two, you're going to have something like this. And so you have C, which is 14. And then you have the other C parallel, which is also 14. Now, these are connected in series. So the series capacitance will be 1 over 14 plus 1 over 14 to the minus 1, which is 2 over 14. If you flip it, you get 14 over 2, and that will be 7 microfarads. So the correct answer is D. Okay, and number 19, you have the dimensions, and they're asking you to find the charge given the voltage. So Q is equal to C times V, but we also know that C is equal to epsilon naught A divided by D. That's why they gave you this constant epsilon naught right here. Okay? The area is given. You can find the area by length times width, but remember to convert to meters. And then the separation is 1.15 millimeters. And since the plates are separated by paper, that you have to factor in the dielectric constant into the equation, which is 3.7. So let me rewrite that. If the space between the plates was just air, then you would just have the equation that I wrote originally. C equals kappa epsilon naught A over D. So if the material between the plates is air, then kappa is 1. You just have epsilon naught A over D. But since it is paper and the constant for paper is given, you're going to use 3.7 for kappa. And then, of course, you have your V, which is 1.4 volts. Okay, your D is 1.15. That's D. And from here, find A. That's your epsilon naught. That's your kappa. And that's your V. Okay. And so the correct answer for number 19 will be D if you do the calculations. And then number 20, what is the equivalent capacitance of the combination shown? So again, this is parallel. 20 plus 20 is 40. This is also parallel, which is 60. And then you end up with 40 and then 60, which is series. So C series is 1 over 40 plus 1 over 60 minus 1. And that will be A.
Okay, Dr. Long, for
Yes.
19, did you want us to use this Q equals C over V or the C equals the dielectric constant times that one?
Q equals C times V.
Okay.
And C is A, kappa A, epsilon naught over D. So you calculate C from here. V is given directly. You multiply the two. Okay?
Okay.
They're asking for charge, which is Q. They've given you V. What is missing is C, but you know enough information to find C from this equation. Kappa is given, the area is given from the length and width, the voltage is given, then the separation, that's the distance between the plates, is given. That's your D.
Okay.
Okay, number 21. Number 21, the answer is positive x direction. The answer is B. So this is Newton's third law. So you have two charges, Q1, Q2. So if this charge exerts a force of 6.4 newtons this way, how much force will this charge experience? The same force in the opposite direction, right? Remember, the force is equal to K times Q1, Q2 over R squared. And this force is also K times Q1, Q2, R squared. The same numbers. So you're going to have the same value, but in the opposite direction. Okay.
Okay.
All right. So that concludes our review session for tonight. I will be available probably afternoon around 1 o'clock tomorrow. So if anyone still has questions they want to clear up, feel free to email me and we will talk. But I need to run now and catch up with the next class.
Okay.
Okay. And I'll try to make these recordings available by tomorrow on Blackboard.
All right.
All right.